Hello everyone. On this video we will be looking at integrals that result in inverse trig functions. Okay, so to do that, first we're going to look back at our inverse derivatives. So you see the derivative of sine inverse was 1 over 1 minus x squared. Derivative of cosine inverse is negative 1 over 1 minus x squared. So you see the sine and the cosine basically the same, just cosine is negative, sine is positive. The derivative of tangent inverse of x is 1 over 1 plus x squared. And the derivative of cotangent inverse of x is negative 1 over 1 plus x squared. Okay. You have the derivative of secant inverse, which is 1 over the absolute value of x times the square root of x squared minus 1. And the derivative of cosecant inverse, which is negative 1 over the absolute value of x times the square root of x squared minus 1. Okay, so now we're going to look at what happens when we integrate both sides. Okay, so I'm going to leave this up here so this shows. So if we integrate both sides of this equal sign, of course the derivative cancels out, and we end up with the integral of 1 over the square root of 1 minus x squared with respect to x is equal to sine inverse of x plus c. Okay. And again, if we integrate both sides here and we pull our negative out to the front, the negative integral of the square root of 1 minus x squared with respect to x is cosine inverse of x plus c, or if you have that negative out in front, remember this part is just this, so it could be negative sine inverse of x. Okay. Now, in most cases, you will see your answer in this form, but if you see it in this form, it's not incorrect. It could be in either form. This here is just more popular. All right, so again, with the tangent inverse of x, if we integrate both sides, the derivative and integral cancel each other out, so we get the integral of 1 over 1 plus x squared dx equals tangent inverse of x plus c, or the negative integral of 1 over 1 plus x squared dx is equal to cotangent inverse of x plus c. And once again, since the negative is out in the front, this part is just equal to this, so it could be negative tangent inverse of x plus c. And again, this is the more popular form of the answer, but like I said, if you see it as cotangent, it's not wrong, just different ways to write the same answer. All right, so we have the integral of 1 over absolute value of x times the square root of x squared minus 1 if we integrate both sides. Put it down just a little. We integrate both sides for this one. Okay, now if we integrate both sides for this one, we end up with the integral of 1 over absolute value of x times the square root of x squared minus 1 dx is equal to cosine inverse of x plus c. Or, once again, if we pull that negative out to the front, it could equal negative sine inverse of x plus c. And again, this is the most popular form of the answer, but it's not the only form. Okay, so remember, if these ones with the checks, they're the ones you're most likely to see as the answer, but the ones without the checks are also correct. Okay, I just want you to be able to know both forms of it so you won't look at a problem and go, okay, well, he told me it will be this and it ended up being this. I want you to be able to look at it and tell both forms of it. All right. So if you are still writing this, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next page. And those are our general forms. Okay. So if we have the integral of du over a squared minus u squared, of course, where a is just any constant, and our u is a function of x, or our u could be a function of t, or it could be a function of s. We just happen to pick x as our variable, but it could be any variable at all. Okay, so the integral of, instead of having the du on the front or in the back end, we just put it up top. That's all. The integral of du over the square root of a squared minus u squared is equal to the sine inverse of u over a plus c. And once again, you have the negative integral of du over the square root of a squared minus u squared is equal to cosine inverse of u over a plus c. Or, again, since the negative is brought out to the front and we have that as our sine inverse, it could be the negative sine inverse of u over a plus c. And once again, this is the more popular form, but it's not the only form. All right, so we have the integral of du over a squared plus u squared. That's going to equal 1 over a times the tangent, times tangent inverse of u over a plus c. Again, if you have the negative du over a squared plus u squared, that's going to equal 1 over a times the cotangent inverse of u over a plus c. Or, again, if you have the negative of 1 over a, it could be the tangent inverse of u over a plus c. Okay. And last but not least, if you have the integral of du over u times the square root of u squared minus a squared, that's going to equal 1 over a times the secant inverse of the absolute value of u over a plus c. And if you have the negative integral of du over u times the square root of u squared minus a squared, that's going to equal 1 over a times cosecant inverse of the absolute value of u over a plus c. And once again, if you have that negative factored out, it could just be negative 1 over a times secant inverse of the absolute value of u over a plus c. Once again, these forms with the check marks are the most popular forms, but not the only one. So in the examples, you will see the answer written as both. Okay. So if you are still writing, feel free to press pause and finish up, but I'm going to go ahead and move on to our verification. Okay. Now, in most textbooks, they will prove the sine inverse, but the others are a little more complicated with the proof, and I want to just do the same one that appear in most textbooks. And cosine is pretty much the same. So what I'm going to do is just going to verify I'll verify this one, that 1 over a tangent inverse answer. All right, so if you are still writing this, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our verification. Okay, so we have, let's say, 1 over a times the tangent inverse of u over a plus c. What if we find the derivative of that? Okay, so if we get our 1 over a and factor it out, our tangent inverse, of course, you want to remember that the derivative of tangent inverse of u is equal to u prime over 1 plus u squared. Okay, so this is going to equal u prime over a, we have our u over a, divided by 1 plus u over a squared. Since our u is just u over a, it would be u over a squared. Okay, so what if we get this a and factor it out? And move that right over there. So we have 1 over a times 1 over a. So we have 1 over a squared times u prime. And here we'll have u squared over a squared. So what if we have that u squared over a squared, and we turn that 1 into a squared over a squared. All right. So if we go ahead and combine those terms, because they have the same denominator, we can go ahead and combine it. So we have 1 over a squared, not equal to, times u prime over a squared plus u squared over a squared. Okay. Now, what if we go ahead and multiply this by a squared over a squared? Okay, so if we times a squared over a squared, this a squared is going to cancel this one. Well, I'll go ahead and just simplify it first. So you have u prime times a squared over a squared plus u squared all over a squared times a squared. Okay, so we see here that this a squared and this one cancels out, this one and this one cancels out. So we end up with u prime times a squared plus u squared. Okay, so what does this tell us? This tells us that u prime over a squared plus u squared is equal to the derivative of 1 over a tangent inverse of u over a plus c. Okay, so u prime, let me move this up, over a squared plus u squared. Now, if you remember, u prime is equal to derivative of u with respect to x. So if we solve for du by multiplying both sides by the dx, we have du is equal to u prime dx. Okay, so we have du dx over a squared plus u squared. Okay, so that's going to equal the derivative with respect to x of 1 over a tangent inverse of u over a plus c. Okay, so these two are equal and these two are equal, so all three of them are equal. Okay, now what if we integrate these two? With respect to x. Okay, so if we integrate du over a squared plus u squared with respect to x, and we integrate derivative with respect to x of 1 over a tangent inverse of u over a plus c, the integral with respect to x and dx cancel each other out. So actually we end up with the integral of du for a squared plus u squared is equal to 1 over a tangent inverse of u over a plus c. Okay, because remember, we're not integrating with respect to x, we're integrating with respect to u in this case. All right, so that's just verification. Again, it's not a proof, but it is a way to kind of show that it's true. All right, so if you are still writing this, feel free to press pause. Again, this is not something that's urgent to learn when you're doing integrals, but it's good to know. All right, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our examples, the fun part. All right, there we go. What if we wanted to evaluate the integral of -8 over the square root of 81 minus 9x squared? Okay, so we kind of look at the form. Okay, and this form really looks like the integral of 1 over the square root of a squared minus u squared du. Okay? And the more you practice, the more you'll be able to look at it and go, okay, this looks like this one. Okay, and we know that's equal to sine inverse of u over a plus c. Okay, so now pretty much the same form. So now what do? We rewrite our original. So we know if we get that -8, we can go ahead and bring that out to the front. We have -8 times the integral of 1 over the square root. And instead of 81, we'll make that 9 squared. And instead of 9x squared, we make that negative 3x, and that whole quantity squared. Dx. Okay. Now we see here, if we match it up, your a is equal to 9. And your u is equal to 3x. Now since your u is equal to 3x, we know that your du is equal to 3 dx. We divide both sides by 3, our du over 3 is equal to dx. So these are the 3 we're going to need moving forward. We have our a, we have our u, and we have our dx. We have to solve for dx. And that's when we start replacing. So you have -8 times the integral of 1 over the square root. You can put a squared if you want to. You don't have to. So you can say 9 squared or a squared, whichever one you're comfortable with, minus your 3x squared, which we're going to go ahead and just make that u squared. And our dx, remember that's du over 3. That's du over 3. Okay. So what we're going to do, we're going to go ahead and get that 3 in the denominator and bring it over. So you have -8 over 3 times the integral of 1 over the square root of your a squared minus your u squared. And go ahead and bring the du up top. Okay. So we know once it's in that form, it's going to equal -8 over 3. Don't forget that coefficient. It's really easy to do, so you don't want to do that. So just using this, we have -8 over 3 sine inverse of u over a plus c. Okay, so now we go ahead and replace our u and our a. So that's -8 over 3 sine inverse of u, which is 3x, over a, which is 9, plus c. And we can, let me clean up that 3 a little bit. There we go. And we can simplify this, so we end up with -8 over 3 sine inverse of x over 3 plus c as our answer. Okay. Again, this is the most common. Or you can change the sign, make it 8 over 3 cosine inverse of x over 3 plus c. And again, this is the most common. Not the only, but it is the most common. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if we wanted to evaluate the integral of negative 7 over the square root of 100 minus 49t squared with respect to t? Okay, so what I want you to do is press pause and using the same method on the previous previous example, try to solve this one on your own. All right, so I'm assuming you've paused it and worked it out. So let's verify. Okay, so again, looking at the form, it kind of looks like the integral of 1 over the square root of a squared minus u squared with respect to u. And we know that's equal to sine inverse of u over a plus c. Okay, so what do? We go ahead and rewrite this. So we get our negative and our 7, bring that out to the front. So you have negative 7 times the integral of 1 over the square root. Instead of 100, we're going to make that 10 squared. Minus 49t squared, we're going to make that 7t. And that whole quantity squared. Okay, and that's with respect to t. Okay, so now we see here that our a is equal to 10, our u is equal to 7t, which means our du is going to equal 7 dt. We divide both sides by 7. We have du over 7 is equal to our dt. Once again, those are the three that we will need moving forward. Okay, so we have negative 7 times the integral of 1 over the square root of your a squared. Remember, that's your a squared here. So you can write a squared or you can write 10. 10 squared. We'll go ahead and write 10 squared. Minus u squared, because your 7t is equal to u. So you can go ahead and make that u squared. Or you can write 7t squared, completely up to you. And your dt is equal to du over 7. Okay, so we go ahead and replace that with du over 7. And we go ahead and bring that 7 out to the front. So you have negative 7 over 7 times the integral of 1 over the square root of 10 squared. Let me clean that up a little bit. Minus u squared. And that du, we're just going to put that right up there. Okay, and we know that's going to equal negative 7 over 7 is negative 1. So negative 1 times sine inverse of u over a plus c. Okay, so we know that our u is equal to 7t. So let me close that up there. We know our a is equal to 10. So that's negative 1, or you can just put negative sine inverse of 7t over 10 plus c. Or you can change the sign of the coefficient and just make that cosine inverse of 7t over 10 plus c. And again, this is the most common. Okay, not the only, oh, sorry, but let me move that up. Not the only form of the answer, but the most common. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right, there we go. Okay, so what if we have the integral of 3 over 4 plus 100 squared with respect to x? Okay, so if we look at this one, we kind of see that it's a bit familiar. It sort of looks like the integral of 1 over a squared plus u squared du, which is equal to 1 over a times the tangent inverse of u over a plus c. All right, so what we're going to do is we're going to go ahead and just rewrite it. Rewrite our original. So we get that 3 and just bring it out to the front. Times the integral of 1 over, instead of 4, we're going to make that 2 squared. Plus, and instead of 100x squared, we're going to make that 10x squared with respect to x. Okay, so now matching these up, your a is equal to 2, your u is equal to 10x. So if your u is equal to 10x, that means your du is equal to 10 dx. Divide both sides by 10. That means du over 10 is equal to your dx. Now once again, we have the 3 parts that we need to move forward. Okay, so we have our 3. Don't forget your coefficient. So we have 3 times the integral of 1 over your a squared. Again, you can put a squared or you can put 2 squared. Doesn't matter. 2 squared plus, you have your 10x. You can put 10x, or you can put u squared. Doesn't matter. I just put u squared. And dx, since dx is equal to du over 10, we have du over 10. All right, so we're going to go ahead and get that 10 and just bring it out to the front here. So we have 3 over 10 times the integral of 1 over 2 squared plus u squared. And that du, we're just going to move it right here. Okay, and that's going to equal 3 over 10 times 1 over a, tangent inverse. Oh, forgot my end here. Moving a little too fast. Tangent inverse of u over a plus c. Okay, so we go ahead and plug in our u's and our a's. So we have 3 over 10 times 1 over a, so that's 1 over 2. Tangent inverse of u over a, just 10x over 2, plus c. Okay, so we go ahead and we distribute that 3 over 10. We'll call that constant number 1. Okay, so you have 3 times 1, which is 3. 10 times 2 is 20. So you have 3 over 20. Tangent inverse, 10x divided by 2 is 5x. Plus 3 over 10 times a constant will still give you a constant. So we make that plus c. All right. Or change the sign. Negative 3 over 20. And it becomes cotangent inverse of 5x plus c. And once again, this one is the most common form of your answer. Oh, move that up. There we go. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to the next example. There we go. There. So if you wanted to evaluate the integral of negative 9 over 16 plus 4x squared with respect to x. So what I want you to do is press pause and try this one on your own. All right, assuming you've paused it and worked it out, so let's verify. Okay, so you notice this one looks an awful lot like the integral of 1 over a squared plus b squared which is equal to 1 over a tangent inverse of u over a plus c. So we go ahead and rewrite it. Okay, we get our exponent, bring that out to, not exponent, our numerator, and bring that out to the front. They have negative 9. So that leaves us with 1 over, and instead of 16, we're going to make that 4 squared. Plus, and instead of 4x squared, we're going to make that 2x squared with respect to x. Okay, so in this case, our u is equal to 4. Our a is equal to 4, our u is equal to 2x. Sorry about that. A is equal to 4, u is equal to 2x. Which means our du is equal to 2 dx. Divide both sides by 2. We have du over 2 equals our dx. And once again, we have everything we need here to move forward. Okay, so you have negative 9 times the integral of 1 over 4 squared. Of course, you can put a squared if you want to. You don't have to. 4 squared plus 2x squared, which is going to make that u squared, since 2x is equal to u. And dx is equal to du over 2. So we go ahead and replace that. And again, we're going to get our 2 and just move that out to the front. So you have negative 9 over 2 times the integral of 1 over 4 squared plus u squared. And our du, we're just going to put it right up there. And we know that's equal to negative 9 over 2. Don't forget that coefficient there. Times 1 over a tangent inverse of u over a plus c, or we'll call that c1. That step really isn't necessary, but just trying to be thorough. Okay, so you have negative 9 over 2 times 1 over a, so it's 1 over 4, tangent inverse of u over a, so you have 2x over 4, plus negative 9 over 2, or still make that c number 1 till we distribute. So if we go ahead and distribute, negative 9 over 2 times 1/4, negative 9 times 1 is of course negative 9, 2 times 4 is 8, so you have negative 9 over 8, tangent inverse, and this can be simplified to x over 2, plus negative 9 over 2 times a constant, still a constant, so we'll call that c, which is your answer. Or, once again, you can change the sign and make that 9 over 8 cotangent inverse of x over 2 plus c. And again, that's the most common. Okay, so remember, the cofunctions aren't always the most common, but they are possibilities. So I just want you to be aware of that and know them when you see them. All right, so if you're still writing, feel free to press pause. But we're going to go ahead and move on to the next example. So what if we wanted to evaluate the integral of negative 1 over 5t times the square root of 25t squared minus 25? Okay, so if you see here, it looks an awful lot like the integral of 1 over u times the square root of u squared minus a squared with respect to u, which equals 1 over a times secant inverse of the absolute value of u over a plus c. Okay, so what we do, of course, is we rewrite. Okay, so we get that negative, we can just bring that right out to the front. So we'll go ahead and just make that negative 1. times the integral of 1 over 5t times the square root, and instead of 25t squared, we make that 5t and that quantity squared. Instead of minus 25, we make that minus 5 squared with respect to t. Okay, so of course, our u is equal to 5t, which means our du is equal to 5 dt, and divide both sides. That means that du over 5 is equal to our dt. You have that, and you have that, and we know here that our a is equal to 5. So once again, everything we need to move forward. Okay, so you have negative 1 times the integral of 1 over, you have 5t, which is your u. You can put 5t or you can put u, doesn't matter, times the square root of u squared minus your a squared. I'll just go ahead and put the 5 squared here. With respect to t, remember dt is equal to du over 5. Du over 5. And we get that 5 and we bring it out to the front. So we have negative 1 over 5 times the integral of 1 over u times the square root of u squared minus a squared. And that du, we're just going to move it right up there. Okay, so that's going to equal negative 1 over 5 times 1 over a secant inverse of the absolute value of u over a plus c. Okay, so we go ahead and fill in our a's and our u's. So 1 over a ends up being 1 over 5 secant inverse of the absolute value of u, so the absolute value of 5t, over a, which is 5, plus c, or c number 1. Again, this step isn't necessary, but trying to make sure I cover all bases. So we go ahead and distribute. Negative 1 over 5 times 1 over 5 is negative 1 over 25. So secant inverse. Absolute value of 5t over 5. We can go ahead and separate those as the absolute value of 5, which is 5, times the absolute value of t. So the two 5's cancel out. So we end up with just the absolute value of t plus our constant c. Once again, you can change the sign. This is negative, so we'll make this positive. 1 over 25 cosecant inverse of the absolute value of t plus c. And again, that's the most common. There we go. All right. So if you're still writing, feel free to press pause, but we're going to go ahead and move on to our last example. No, second to last example. We have one more after this one. Okay, so what if you wanted to evaluate the integral of 8 over the square root of 81t squared minus 64 times 9t with respect to t? So what I want you to do is go ahead and press pause and solve this one on your own. All right, so I'm assuming you've pressed pause and worked this one out. So let's verify. Okay, so if you remember, this looks an awful lot like the integral of 1 over u times the square root of u squared minus a squared with respect to u. And we know that's equal to 1 over a secant inverse of the absolute value of u over a plus c. So we rewrite. Okay, we get that 8, bring it out to the front. You have 1 over, and instead of, we leave that 9t as it is. That 81t squared, we just make that 9t squared minus 64, and we're going to turn that into 8 squared with respect to t. Let me clean that t up a little bit. There we go. Okay, so you see here, our u is equal to 9t, and our a is equal to 8. So if our u is 9t, our du will equal 9 dt. Divide both sides by 9. Du over 9 is equal to your dt. And once again, we have everything we need to move forward. Okay, so we have 8 times the integral of 1 over 9t. We're just going to go ahead and put u. If you want to put 9t there and leave it, you're perfectly okay to do that. So you have u times the square root of u minus a squared. You can put a or you can put 8 squared. I'll just put the 8 squared. Our dt is du over 9. We have du over 9. And once again, we're going to get that 9 and just move it forward. They have 8 over 9 times the integral of 1 over u times the square root of u squared minus 8 squared. And that du, I'm just going to put that up there. You can leave it on the side if you want to. Putting it up top is just my personal option. Okay, so we know that's going to equal 8 over 9 times 1 over a times secant inverse of the absolute value of u over a plus c. Okay, so that's going to equal 8 over 9 times 1 over a, so 1 over 8 times the secant inverse of the absolute value of u, so the absolute value of 9t, all over a, which is 8, plus c. Okay, so we go ahead and distribute. Oh, forgot my c sub 1. 8 times, well actually 8 over 9 times 1 over 8. The 8's cancel out, so we end up with just 1 over 9. So we have 1 over 9 secant inverse. Remember, absolute value of 9t, you can factor it out and say absolute value of 9 times absolute value of t. Absolute value of 9 is just 9. So we have 9 over 8 times the absolute value of t. You can put the absolute value of t on the side if you want to, completely up to you, plus c. Okay, or you can change the signs, make it negative 1 over 9 cosecant inverse of 9 absolute value of t over 8 plus c. But of course, this one is the most common. All right. So if you are still writing, feel free to press pause and finish up. But we're going to go ahead and do one more example. For real this time, just one more. Now what if we wanted to evaluate the definite integral? Okay, so the integral from negative square root of 3 over 3 to 0 of 7 over 2 plus 2x squared with respect to x. Okay, so I want you to try this one on your own, but I'll give you a hint. 2 plus 2x squared, that can equal 2 times 1 plus x squared. Okay, so what I want you to do is go ahead and press pause and try this one on your own. All right, so we're going to go ahead and assume you've pressed pause, and we're going to verify your answer. Okay, so your first step for a definite integral is you're going to integrate the same as you did on the previous examples. Okay, then after that, you're going to use the fundamental theorem of calculus to solve it. So we know that this looks a lot like the integral of 1 over a squared plus u squared du is equal to 1 over a tangent inverse of u over a plus c. Looks a lot like it. Okay, so again, we're going to rewrite it. Okay, so you have your integral from negative square root of 3 over 3 to 0 of 7 over, we're going to get that one, we're going to rewrite it like this. So you have 2 times 1 plus x squared dx. Okay, so we're going to go ahead and factor out the 7 over 2. We have 7 over 2 times the integral of negative square root of 3 over 3 to 0 of 1 over 1 plus x squared. We're going to make that 1 squared plus x squared with respect to x. Okay, so remember, once we factor out the 2, this is our only denominator. Okay, so we see here, your a is equal to 1, your u is equal to x, which means your du is equal to dx. Okay, everything we need to move forward. Okay, so that gives us 7 over 2 times the integral from negative square root of 3 over 3 to 0 of 1 over a squared. Let's move that up some. So we just make that 1 squared instead of our a squared plus u squared. Again, if you want to make it x squared here, you can. I'm just going to make it u squared. And dx is equal to du, so we have our du. We don't really need that since it's already in the right form. And again, if you want to move your du up there, you can. But we know this is going to equal 7 over 2 times 1 over a tangent inverse of u over a. Oh, and we're actually on a definite integral. We don't need our constants. Okay, and we know that's going to be from negative square root of 3 over 3 to 0. Okay, so we go ahead and replace our a's and u's. We have 7 over 2 times 1 over a, so that's 1 over a is 1. Tangent inverse of u over a, so that's x over 1. We know that's from negative square root of 3 over 3 to 0. So that's going to equal 7 over 2 tangent inverse of x from negative square root of 3 over 3 to 0. All right, so now we go ahead and apply the fundamental theorem. Okay, we have our 7 over 2, so that's going to equal, move that over a little bit to give us more room. 7 over 2 times, we plug in the 0 first, tangent inverse of 0 minus the tangent inverse of negative square root of 3 over 3. Okay. Move that up. So we have negative, not negative, 7 over 2. And the tangent inverse of 0, tangent of what value will give you 0? Well, tangent of 0 is 0. So that's 0 minus tangent of what value will give you negative square root of 3 over 3? Well, negative pi over 6. Okay, tangent of negative pi over 6 is negative square root of 3 over 3. Okay, so that's 7 over 2 times positive pi over 6, which gives us 7 pi over 12. Okay, and that's how you would evaluate your definite integral. First, you integrate as normal, like we did before, then you apply the fundamental theorem after that. All right, so hopefully this all made sense, and I'll see you on the next video.